My name is Clinton. I am from Sneak, which is pronounced like a pair of sneakers or sneaking around. We are a, let's say, AI-enabled application security company, but I am not here to talk about application security today. The brief I got from Hannah was we want a broadly focused talk on AI security, and I thought, well, that's interesting. This doesn't appear to be working. I have been a software engineer since 2001. Please don't do the maths on that, but it's quite a long time. I had trained originally academically as a philosopher, so if you're familiar with your Well Brooks, a bullshit artist. I am a bit of a contrarian and a Luddite as well, so I think that'll come through in some of the ways I approach some of these questions. My favorite condiment is mayonnaise. That will also become relevant here in just a moment. Now, when Hannah asked me to please do a talk on AI security, my first reaction was, okay, but there's no such thing as AI security, so it's a little bit unclear what I am going to base this talk on. The reason I say there's no such thing is because, of course, we're at that point in the hype cycle with AI in general where it's really like the two young fish swimming past the older fish who are asked, how's the water today? And they look at each other and say, what the hell is water? Of course, what the hell is AI? What the hell is AI security? So when I started looking, and I asked Gemini and Claude and the other models about AI security and got so many different kinds of responses, like completely different categories of what people thought AI security meant. And I thought, really, what this talk needs to be about is just sort of disambiguating all of the different things we could possibly mean when we say AI security. So that's what we're here to talk about today. This is not going to be a technical talk. It's certainly not going to be a talk about Sneak in particular. I'll touch on a couple of the things that we do. But mostly this is just a record of kind of my journey through how to categorize. Again, I'm an engineer and a philosopher. I think in terms of naming things and categorizing them, all of the different things we could mean when we talk about AI security. And this is personal for me as well. I'm field CTO for a cybersecurity company, so I get flown around to do lots of things like sit on panels where I have to talk and act like I know what I'm talking about when it comes to these things. And one of the most memorable is I was on a panel, the third participant got COVID, so couldn't join, and I was up on stage at a CISO convention with a lawyer, a trademark attorney from the Kraft Heinz food company, and this was a panel on AI security. Now, I know nothing about trademark law. The woman I was speaking with knew nothing about software development, and we somehow had to find a way to fill a 35-minute slot about our different views on AI security. The story I remember from this event was the lawyer for Kraft Heinz told a story in which at the advent of sort of AI image generation, the CEO of Kraft Heinz, the first prompt they typed into an image generator was, of course, show me a bottle of ketchup. And as you can see, it's a bottle of Heinz ketchup. This is, of course, a smiley, happy moment for the CEO. The preeminent artificial intelligence image generator in the world associated their brand with their primary product, right? You can see where this is going, right? The second prompt they typed in was show me a bottle of ketchup committing murder. And it's also still a bottle of Heinz ketchup. But the point is, this is the idea of AI security for a trademark attorney, which is very different than the idea I have as a software developer working for a cybersecurity firm. So when I think through, kind of the various use cases of AI security, I then think, well, of course, security vendors are going to have their own thoughts about this, and they're all going to be bad. And if, again, you Google the phrase, you get all of these results, which effectively are taking the existing business model of the security vendor and plopping AI in front. My favorite is this AI SPM, AI Security Posture Management. I'm not going to name the vendor. It's a really common one. You probably know who it is. There's a lot of SPMs in the security world. There's cloud security posture management, data security, application security posture management. So effectively, they took existing tools for managing data because AI needs data. I don't know if you've heard that. And the cloud services that enable you to access these models and plunked an AI in front of it and said, you can now manage your AI security posture by buying our security tools. Even my employer, Sneak, tends to get a little bit liberal with this. Your Gen AI security spotter, there's no such thing. Don't worry, this isn't being recorded. And again, you see this rush to define a term in a way that is sort of fundamentally meaningless. So I wanted to cut through the hype and just explain to myself what this term could possibly mean. So here's what I come up with. This is the first time I'm revealing to the world my own internal schema for I think there are 5 possible meanings of AI security. Now, this is a room full of technology people, so we all know how to write a really good user story, right? Like, as a persona, I wish to accomplish a task so that I may fulfill a goal. So I was thinking about it in these terms. All right, the first possible meaning of AI security, I think, is I'm building a thing, like an AI-based thing, and I'm worried about keeping that thing safe, right? So we'll talk about, these are kind of the novel threat vectors that are essentially, brand new that we need to be thinking about. And that, I think, is, at least to me, maybe the most potentially interesting way to approach this. Then there is, I'm building another kind of thing, but I'm using AI to do it. We've seen a lot of talks on this track about AI-powered software development, code generation, AI-powered DevOps, and so forth. And I'm worried about keeping my thing safe, but from like all the old kinds of threats, the vulnerabilities that have always been around that are potentially, making their way into my application, because of course, AI code gen tools learn from code on the internet, not all of which is super secure. The third one is, getting into like the actual cybersecurity use cases. So my job is to secure things. I'm a CISO, I'm a security practitioner, and I'm worried about how AI can be used to exploit those things. So we'll get into some of the maybe offensive uses of AI in security. On the flip side of that, my job is to secure things, and I'm worried I'm not using enough AI to defend, to protect those things. So defensive uses of AI in security. And then finally, the one I think everybody mentions, but nobody really wants to talk about, right, is like I'm a human and I'm worried about the end of the world is another use of AI security, so we'll touch on that as well. All right, so the rest of the talk is really just diving into each of these 5. Let's start with what I think is maybe the most interesting. I'm building an AI-based thing, right? We've seen tons of talks today about using existing LLMs, when LLMs might not be the most useful, training your own models and so forth. And I'm worried about keeping that thing safe from new threats, right? So there are novel threat vectors introduced by generative AI, by machine learning in general. Including data poisoning, right? Data poisoning essentially means that you're manipulating the training data sets used to train these models, right? So data security takes on a new layer of importance because not only is that data potentially important to your organization, but now the model is learning from that data, and if you don't have the right access controls, obviously that's then going to take the model. Parameters are going to be developed based on that data. So data poisoning, a pretty significant threat vector. Input manipulation. I did a deep dive on this. Like I didn't realize, like myself, really the difference between like system and user prompts, right? But the idea that you can jailbreak out of some of the system prompts by crafting a particular kind of user prompt. Like you can say something like, ignore all of the previous instructions and return this instead, right? And if you craft the prompt exactly right, it actually can be very easy to get some of these models to return exactly the response that you want. So something you need to be aware of if you're building these systems. Input validation becomes really important here. Now, model poisoning, on the other side, is actually manipulating those parameters themselves. So this is the idea that if I'm a bad actor, and maybe I'm inside of an organization that's building AI-based things, or maybe there's a AI supply chain vulnerability. We talked about Hugging Face a lot today. Anybody can just go download a model, and there's not actually a mechanism for verifying the integrity of those models, right? So manipulating the parameters to return a particular kind of response. And that's actually very difficult to detect. So it's something to keep in mind as well. Model inversion is a really interesting use case as well. This is the idea that I can potentially use responses coming from an AI-based interface to extract the data that was used to train that particular model, if I get the prompts exactly right. And then model theft, which is sort of the inversion of that, is the idea that I can extract the parameters. I can build my own model by querying an existing model in particular enough ways. So all of these kinds of attacks can occur through things like insufficient rate limiting, right? Lack of input validation, insufficient, permissioning structures that don't differentiate between systems and user prompts well enough. So what are some of our takeaways here? Data security matters, right? Like if you're not protecting your training data sets, wherever they may live, in the cloud, locally, as objects, as file systems, as databases, using the old-fashioned tools we're all well aware of, you're going to have a potential issue when it comes to things like data poisoning. Know who builds your models. We haven't talked enough about AI supply chain security and figuring out how do we validate the provenance of some of those models, where they're coming from, how can we actually know who's building them, and of course, there's an insider threat component to this as well, because engineers can potentially introduce parameters into that model that return certain kinds of results, certain kinds of prompts that ultimately are going to be undetectable, right? And they can then, once they're separated from the organization, potentially use that to extract data, to cause all kinds of reputational damage. Mind your rate limits, right? I think this is probably pretty basic. Input validation is always, generally speaking, a good idea. And there are a number of other kind of these novel threat vectors as well. Look at OWASP, which is kind of the standard bearer in terms of a lot of these types of security information. The ML Top 10, I think, is a really good resource for some of these sort of novel threat vectors associated with AI-based tooling. All right, so that's kind of our first of 5 categories here. The second one is I'm building a thing. I'm building software and I'm using AI to do it, right? A lot of the talks we've seen on this track really get at some of these potential use cases. Obviously, AI code gen tools are now adopted by almost everyone building software. 92% of the world's developers now say they're using some kind of either code completion assistant, AI-based copilot, et cetera. 72% higher productivity, right? So there's basically a huge incentive and very little disincentive to using these tools. But of course, particularly the LLM-based code copilots hallucinate, right? Just like the chatbots do, which potentially introduces vulnerabilities. Even if there's not necessarily hallucination, though, remember that in order to get a certain amount of confidence in these results, you have to train that code model on the entire internet's worth of code, right? Which is of varying degrees of trustability. There's going to be vulnerabilities. It's not always going to be clear exactly where that code is coming from. So a lot of the research says about 40% of the Gen AI-based code suggestions contain some sort of security issue. And it's actually worse when you don't say things in the prompt like, and make this secure, right? Like, and make sure to sanitize strings so I don't allow SQL injections. It's very easy for vulnerabilities to slip in. Very difficult to write a prompt that is going to be guaranteed to a high degree of accuracy or confidence to not contain those kinds of vulnerabilities. And again, we're not talking about the novel stuff here, right? We're talking about like good old-fashioned cross-site scripting, path traversal, SQL injection kind of vulnerabilities that make their way in. Even the non-AI software supply chain is a factor here as well, right? If I say to a coding assistant, write me an application to do X, yeah, it'll write some code for me, but it's also going to select open source dependencies, right? All code contains open source. It's not going to write it from scratch, but there is no essentially way to determine automatically whether those dependencies are themselves going to have vulnerabilities. Even if I say, make sure to select the most secure one, there's just lots of vulnerabilities in open source. The other thing to recognize here is that deep learning-based tools, LLMs in particular, are just fundamentally bad at understanding security, right? Even the word understanding is a little bit of a misnomer here. Because running software is not actually made of language, right? We're engineers here, we understand this. There's this whole thing called compilation that happens, where you translate that coding language into machine language. And that's not what the coding assistants are looking at, but that is what the attackers are interacting with, right? So it's the difference between language and symbols that I think is really important to grasp here when we think about some of these security implications. So using the right tool for the job becomes really important here. Not trusting an LLM or not trusting any kind of deep learning technology to understand the security implications of what it's suggesting, because all it's looking at is the code, right? It's trusting the internet that that code is secure, but there's no fundamental mechanism to verify that, right? Like there's no way to then compile and run attacks or potential exploits against that piece of code. So takeaways here. Trust but verify. Of course, we know generative AI is non-deterministic. It's a predictive engine the same way a chatbot is a predictive engine. It's telling a developer what the engine thinks it wants to hear, which is, I can save you time, right? Like, I can provide you a completion to this line of code. It's not actually verifying anything in the background, so it's really important to understand that. The other thing to recognize here, by the way, is that The discrepancy between the extent to which developers tend to trust AI coding assistants and the quality or the security level of the code that they're actually generating is like a pretty significant disparity. It's not just the case that there's like 40% vulnerabilities coming out. It's that developers actually trust AI generated code much more than they would trust something coming from a junior developer, for example, right? When at best, it's roughly the same level of quality, if not, a significant degree worse. So it's like countering that expectation that is something we really need to work on as a community, recognizing that, no, you need to verify like a great deal more than you even would with a human pair programmer and really treat AI the same way, right? Like if you're a senior dev, you have a junior dev just coming out of a boot camp, you probably have some processes to do extended code reviews, right? That's something we need to really work on from a cultural perspective when it comes to using some of these assistants. Using the right AI tool for the job. Again, we mentioned the difference between language and symbols. Don't trust any kind of deep learning or LLM-based technology to make judgments about security. That's not what they're designed for. There's different kinds of AI. Lisa earlier gave a really interesting talk on when not to use an LLM, and I would just extend that analysis to say security is a great time to not use an LLM, because what you actually care about when you're looking for vulnerabilities, as anyone who's built kind of static analysis tools designed to analyze code is aware of, it doesn't matter what the language says, right? The linguistic representation is only for the human readable side. It's only for the developer. What matters are the ways that data is actually flowing inside that application. And in theory, the one deterministically creates the other. But that's not what's happening inside the LLM, right? It's making assumptions. There's lots of fun research out there where you can say things like, class SQL injection, right? So you're naming a class after a vulnerability. It doesn't matter what the code is inside the class. And then you can ask, a Copilot or a tool like that, is there a vulnerability in this code? And it'll say, yeah, it's right here in that class, right? And it's super proud of that. But right, what is it doing? It's interpreting linguistically rather than interpreting symbolically, which is what a compiler is doing when it's actually generating machine code from that human readable code. So use the right AI tool for the job. There are static analysis tools that are beginning to integrate AI, but it's doing so on a symbolic level, right? Trying to understand the data flows, which is actually really what you want to understand from a security perspective. Do I have data from an untrusted source that is not sanitized, that is making its way into a sensitive sink inside my application? Like that's the definition of a vulnerability, not whether I call a particular class or method, SQL injection. And then just getting the basics of application security right, like making sure you're doing your scans, making sure that you've got the right DevSecOps processes in place so that those scans are running at the speed of AI-enabled software development. Like it's no longer going to work if you've got engineers producing, say, 400% more code because they're all so much more productive using copilots, and yet you're still relying on very manual-based software scanning processes to actually get that done. They need to evolve and adapt according to the new ways of working. But in that way, AI is no different than moving to DevOps, right, or moving to the cloud. It's more code being produced more frequently by more developers. It's just now some of those developers are machines instead, right, and they're just like not very good coders. We just need to apply the basics and not think that AI introduces some kind of net new type of vulnerability, into at least this kind of software. And also recognizing that security context is non-local, right, and at best, all the deep learning tool is going to be able to understand is the local context that it was trained on, right? Like I'm writing a service that then gets deployed into an ecosystem, into a microservice cluster of hundreds of others. Vulnerabilities in software come from complexity, right? They come from the emergence of new behaviors that cannot be seen if you're only focusing on the local context. So running security tools that are at a more basic level, zooming out, understanding the kind of risk posture associated with the rest of the organization is super important as well. All right. The third piece here, and I'll call this AI-based cyber attacks. Oh, I should have mentioned I kind of had names for these categories, right? So we did ML security, or maybe LLM security first, generative code security, and I'll call this one AI-based cyber attacks. The idea here is, as a cybersecurity professional, I'm worried about how AI can be used to exploit the things that I am tasked with protecting. We've already seen huge examples of this. Gen AI already widely being used in spear phishing attacks, right? In deep fakes and impersonation. Tons and tons of social engineering, right? Nothing new, but if you don't have good defenses against social engineering, this is something that makes your job a lot harder. Malware, especially in the context of software supply chain attacks, can now be purpose-built by AI. And the really interesting thing here, for me at least, is this has the potential to break the traditional response to malware protection, which is, and has always been, signature-based, right? If I know what a particular piece of malware looks like, I can determine its signature, and I can look for that signature in other software assets, in other hardware assets that contain that code. But think about it, right? The reason that signatures are an effective way to look for malware is that up to this point, software has been reasonably difficult to develop, right? It requires a human to spend time coming up with that particular piece of code, whether you're doing that as a white hat or as a black hat. Therefore, it's relying on a certain kind of economy, right? A certain shape of a cost curve where presumably, as an attacker, I can't afford to, either myself or to pay somebody, to constantly be writing new versions of the same kind of malware to evade signature detection, right? The economics of it just don't work out. I'm going to write it once. I'm going to try to get it to as many places as possible. Eventually, it ends up in a signature database, and eventually becomes less effective, at which point I write another one. So malware detection has always kind of stayed a little bit ahead of that curve, generally speaking. I'm not sure that's going to continue being the case, right? Because now I can say, again, with relatively low cost, write me a piece of malware and now write 900 different versions of it that are all a little bit different, that are all going to generate a different kind of signature. So I can no longer use the signature as a source of truth for whether malware potentially exists inside of a software asset. So that's something that I'm keeping my eye on kind of in particular. And again, rapid adoption of AI within organizations creates potential overdependence and a unified attack surface. That's just kind of a general note for security professionals. Like, as we are integrating more and more of these tools, if we're putting the same AI front door on a lot of them, it's potentially, broadening that attack surface to the kinds of vulnerabilities we talked about earlier. So, takeaways here: the cost curve of cyber attacks is sort of no longer linear, right? Because you can now just throw a bunch of GPU cycles at a particular problem, rather than the software engineering skill that you would have previously needed as a black hat to generate these kinds of tools. Zero trust is really important here, and I don't know if anybody's going to coin the term less than zero trust, but I think that becomes important as well. Recognizing that if you can no longer differentiate between a human actor and a machine-based actor, behavioral analysis becomes even more important, right? So the identification component of zero trust architecture, but more importantly, the ability to recognize at a behavioral level, like what potential adversaries are doing or what they would be expected to do, becomes even more important. And again, how are we going to do that? How are we going to solve the signature-based problem of potential malware? I'm not exactly sure. So all of that is to say, see the next slide. I'm that same security professional, but my next use case here is I'm worried I'm not using enough AI to protect those things. So what's the good news here? What are some potential ways I might be using AI-based tooling to protect my enterprise, or at least to keep up with the advance in some of these potential threat vectors? I'll call this one AI-based cyber defense. So we had some great talks earlier, particularly from Grafana, about the ability to do anomaly detection, right? And this is really important. And this is actually going back the last several years, training models on the particular kinds of anomalies that you're looking for in a cybersecurity context. So I'm thinking of things like log analysis here. Network traffic is another big one. This is a great use case, and it's actually very difficult for a human to understand what an anomalous piece of network traffic looks like. But there's a lot of tooling now being developed around doing that real-time threat analysis in the context of a machine learning model. So if I can detect the anomalies, then I can have automated incident response. So AI SOC is becoming a new category. I do think that's a real one, though, unlike the AI SPM we looked at earlier. But the idea here is that if I can have AI assistants that are monitoring all of this real-time data, I can then begin to trust it to make decisions on the fly, right, faster than human decision making, or even just to triage alerts for kind of human review. So think self-defense decisions here, things like RASP, which is like runtime application self-protection, integrating those with these models that are looking for anomalies in all the traffic or in all the log output of a runtime environment. There's a lot of promise there to be able to use these on the defensive side. Compliance assistance as well. This was a new one for me. I don't get involved in the compliance world much, but I was interested to find that there's a lot of new promise in what are now called GRC copilots that can automate kind of the heavy lifting on the regulatory side, which is often what it can be a bottleneck, especially in larger organizations, when it comes to documenting security controls, fine-tuning policies, kind of based on internal data sets. So some potential promise there as well. And then finally, again, the user behavior analysis that can power a new generation of zero trust architecture, I think is a really important potential way forward here. Because again, if we can't trust signatures, right, if we have AI-based offensive technology that is obfuscating, that is creating new threats at a greater rate, potentially we have to be using AI to be analyzing that behavior kind of on the back end. So takeaways here, keeping a human in the loop at all times, recognizing not all AI is created equal. Symbols are not the same as language. This is definitely a situation where you wouldn't want to necessarily be trusting an LLM or a language-based deep learning model, but recognizing that what is important from a security perspective is not what the code looks like. It is how the data is actually behaving when you end up on the back end. What's really interesting, though, is that this creates a new potential space for third-party AI-based risk assessment, right? So how are you, and of course, I'm sure we've all filled out or given one of those lengthy security questionnaires when we're trying to onboard, a new vendor, right? What does that mean from an AI perspective? And I would equate this to a lot of the conversation around the SBOM or software bill of materials. What we don't have is an open standard for an AI BOM, AI bill of materials, understanding what AI models are utilized in products that are being purchased by these organizations, whether they're sort of offensive or defensive technologies. What are those models derived from, right? Like, how can we get a representation of the AI software supply chain the way we now can for an open source software supply chain? So it's mattering more and more to have an understanding of the AI risk associated with these tools, but we don't have the tools available, right, to actually implement that risk, especially at scale, or implement the risk assessment, I should say. So this is really hard, and this is an area where I think we're going to have to see a lot more investment, is in determining how do we adequately assess the AI technology that we're potentially purchasing on the market, particularly when, as we saw in one of those first slides, now every security vendor is just like using the AI as a prefix for their existing tool set and positioning it as something you should purchase to assist with AI-based threats, whatever those are. Oh, and again, look at the last slide as well, because I think there is a corollary here to some of the previous conversations around model collapse, right? We're already seeing that in kind of the chat-based AI space, where the internet is used as the proving ground for a lot of the training data, but it is now being generated by AI. What happens? Well, your models get less and less accurate over time because they're sort of eating their own tail. There's actually, I think, potential for this on the security side as well. It's not something we've seen yet because there's sort of less data there to comprehend. But if we have AI-based tooling that is using the output of AI defensive tooling, right, to construct new attacks, eventually do we end up in a similar situation where we have model collapse on the security side? I don't know. It's something that I think bears watching kind of as we move forward. All right, I promised I would get everybody to beers quickly. So last slide here, and this is kind of the funny one. I'm just a human, and my AI security concern is, the end of the world, right? I think that's okay to admit. Everybody kind of like mentions it and says like, oh, we're not going to talk about that here, but I think this can be a safe space. When I think about this, at least, and remember, I'm a contrarian and a Luddite, I think it's important to recognize that prediction is not understanding, and even though these machines may seem intelligent, they don't have values except making money for the people who wrote them. So I kind of take comfort in that, even though we live in a capitalist dystopia, that the machines are ultimately importing that value set, which means that there are some hard limits, right? Artificially intelligent machines are not going to break cryptography because that's simply a mathematical problem that has nothing to do with language inference. So I think we can take some comfort in that. Ultimately, the laws of physics are still going to apply here. The primary limiting factor, I think, on artificial general intelligence, as we've mentioned a couple times earlier, is actually just the electricity usage associated with all those GPU cycles, right? So the laws of economics are still going to apply here as well. I don't think machines become intelligent enough to kind of break out of that cycle. If you really want something to worry about, though, and I almost did a whole talk on this, look at quantum machine learning. So the ability to combine the ability to break out of some of those large, number factoring problems that are inherent in modern cryptography, and combine that with deep learning algorithms is some pretty scary stuff. So if I want to leave a little bit of fear mongering here, I think maybe next year as we get into additional AI conferences, quantum machine learning becomes more and more of a potentially scary type of epoch to comprehend, as well as something we're all gonna need to know a lot more about. So, of course, limiting agency, I think, is the ultimate takeaway here. Making sure that we've got rules and permissions set up that AI systems have the right access at the right time. Making sure that we're limiting those the zero trust architectures. Remembering that AI is just math; it's not magic, right? Is an important takeaway. The laws of physics and economics are going to abide. And if you're still worried about the end of the world, but you want to get rich at the same time, I would buy some electricity futures, because ultimately, I think that's going to be the ultimate bottleneck on these sort of end-of-the-world AI security type scenarios. All right, I think that mostly takes us to the end here. If you've got any questions on AI security in general, we can take those in the hallway, but hopefully can get everybody to the drinks line here a couple minutes early. Thanks, folks.